Hello dear students, welcome back to my YouTube channel. So today we are going to discuss lecture number 3 of current electricity. I guess I'm audible and visible to all of you, right? Let me check, then we will start class. Yeah, so I am audible. So let us start class now. Okay, so as you know that we are discussing about the change in resistance part, okay? How to get the resistance. Yesterday we discussed two important parameters. One is if the change is less than 5%, we can use the directive formula. Delta R by R into 100 equals to 2 times delta L by L. Okay. And if the change is more than 5, so we need to go with the basic change, final minus initial divided by initial into 100. Okay. Now we will start today's class with some numerical from the previous topic. Okay. So you will like the rhythm of the class. And if you have any doubt about the previous class, you can just let me know. So we are discussing lecture number 3 today. My numerical would be, look now, resistance is given, okay? Resistance is given. The initial resistance is 10 ohm. Done. And the length, the original or the initial length is L. What happens is we now stretch it. We stretch it double length. I guess double length simply indicates is 2L. Double length means 2L. We have to find two things. First is what will be the new resistance. What will be the new resistance? Second part, we need to find percentage change in resistance. Percentage change in resistance. These two things we need to find. Done. Look here. If my length changes to twice, it is twice. So twice simply indicates it is more than 5%. Twice means it is more than 5%. If it is more than 5%, so for that thing, I need to use the formula final value minus initial value divided by the initial value multiplied by the 100. Done. And one more thing, if we have the 5 more than 5, so initial we will take as 100 and final we will take at 200. It is double, no? Yes, sir. We can take it like that, no? So now use the formula. Sir, R is proportional to the L square. This formula we need to use. Done? Look better. I can write R1. R1 is 100. 100 square. R2. What is R2? Sir, R2 is equals to 200 square. I can write it 100 divided by 200 whole square. 20 cancel out, and R1 is how much? 10. So is it 10? It is 10 by R equals to 1 divided by 4. So I guess therefore R came out to be 40 ohm. R2 now. R2 came out to be 40 ohm. Easy? Okay, sir. Now use this formula. I need to use this formula. New resistance. I guess new resistance we concluded it is 40 ohm. For percentage change, I need to use formula final. What is final? Sir, final is 40. Initial is 10 divided by initial is 10 multiplied by the 100. 40 minus 10 is 30. It is 30 divided by 10 into 100. 10 ones are 10, 10 threes are 30, 30 into 100, it is 300. So my change in resistance came out to be 300%. Yes, beta, you can ask me doubt. There is no issue. It is 300%. Okay, if your doubt is relevant, so I will ask. I will just give my comment on it, no? But your doubt should be relevant. Okay. Now, look, in some numericals, now in some PYQs, there is a relation of resistance with mass also. There is a relation of resistance with mass also. So how we can conclude the resistance part now? Look it up. Suppose now, what is R? R is equals to rho L by A. General equation? Yes, sir. If I multiply with L and divide with L, what will happen now? Sir, it is rho L square divided by AL. Divided by AL. In this lecture now, we are doing almost maximum PYQs. Maximum. And we will be doing one topic with 2-3 numericals. Okay, like that. So you will feel that in this particular chapter, if I'm not having any count now, I guess more than 100. Every chapter, my aim is to give you the more than 100 numerical in a one chapter. Okay, that is normal. No? 100 is normal because for every topic we have to do two, three numerical based on the manipulation way, right? Look now, I guess rho resistivity rho is rho, L is L square, area into length is volume. Do you know what is density? Do you know what is density? Yes, sir. Density is mass per unit volume. So therefore, I can write volume equals to mass divided by density. Mass divided by density. You can do one thing, na. You can do one thing. Tomorrow is off. Sunday where we were keeping is off, na. So just watch the first two lectures of electricity. Okay. And from Monday, with electricity, make sure that you attend the electrostatic chapter lecture number first as well. Okay. Every day. I am giving you the basics, definition, derivation, numericals for your boards, for your NEET majorly, then JEE. So tomorrow, make sure that watch those two lectures, electric current 1 and 2nd. Those are basics and with derivational part. From Monday, go with continue my lectures with one lecture from electrostatics as well. I guess my voice is clear, no? There is no sort of issue with my voice now. Look now. So I guess we need to write now rho as it is, L square as it is now. We can just change the volume with mass into density. Mass into density. Now we have a new formula. Resistance is equals to resistivity length square into density divided by mass. One more formula to get our resistance. Is it breaking? No, beta. I guess I'm having the system as well, no, with me. So I will just okay. Due to some sort of network issue, no, it happens, right? So we concluded this sort of. This is also important now because couple of times you will see the numerical in previous aims sort of paper, okay? And this formula is also given in NCRT. It is given, huh? It is given. So I will give a numerical based on this particular formula. Okay. We have same material. We have same material. Same material. And the length of first part is given as 5 and mass of first part is given as 1. It is meter in kilogram in SI system. L2 is 3. M2 is given as Okay, M2 is given as how much? 3. L3 is given as 1. M3 is given as 5. So what we need to find a ratio of resistances. Okay, so we have three wires, three resistances, 1, 2, 3. First length is 5 meter with mass 1 kilogram. Okay, second one is 3 meter with mass 3 kilogram. Third one is 1 meter with mass 5 kilogram. Very good sort of numerical. Okay, how to get it now, sir? I guess if material is same for same material, no, equation is R equals to rho L square density by mass. Material same, it indicates my rho resistivity is same. Done. Same, then density is same. So can I write now R is proportional to the L square by M? Yes, sir. So if we use this one, so I guess my R1 came out to be L square. It is 5, 5, 25, 25 by 1. This one, R2, it is 3, 3 are 9, 9 by 3. This R3 came out to be 1, 1, 5, 5, 25. 5, 5, 25. So therefore I will write R1 is to R2 is to R3 came out to be 25 is to 9 by 3, then 1 by 25. So if I multiply it with what? We can multiply it with something, no? It's 1 by 25, no? Is it 25, no? Yeah, this is my answer. There's no issue now. This is my answer. This is my answer. Easy, no? I guess 1 second. I need to be very clear, na? Yes. Done. One more numerical based on the resistance chapter. Okay. One more numerical. Numerical is like same material. But we have same material. Done. Initial length is L. Now we change the length to 2L. Initial radius is R. We change the radius to 2R. That means we doubled the length and we doubled the radius also. So find final resistance. Hello, Arushi beta. But if you have any doubt, now you can just do one thing. You can just let me know, right? Live classes में यही तो मसला है ना बेटा. अच्छा है कि if you are present ना, if you are having some confusion in the numerical, you can ask me, sir, how you are saying like this, right? You can ask me. Arushi, I guess you are late, right? Yeah. In my Telegram group, after completing the whole lecture, I will be uploading it is PDF form. Okay, don't worry about it. Look now, I guess my R is equals to rho L by A. Done. R equals to rho L by A. Now, look, beta. Can I write it equals to rho L by A? What is A? A is pi R square. Area of a conductor. My conductor is cylindrical form, right? Length is L. This area. It is circle, so it is pi R square. Pi R square. Done. It is pi R square. Now look now. Initially, it is my R initial. R initial means R1. Okay, it is rho L. L is L and whole divided by pi R square. Finally, it is R2. Look, same material means rho is same. Length is 2L. Okay. Pi. What is R? Sir, R is 2R. It is 2R square. Now divide these two. Rho cancel out. L cancel out. Pi cancel out. So I guess my equation came out to be now R divided by R2 is equal to 1 divided by R square whole divided by 2 divided by 2 to the 4R square. R square cancel out. 2 ones are 2, 2 twos are 4. So therefore, R divided by R2 is equals to how much? 2. So therefore, R2 is equals to R by 2. No, no issue, beta. No issue, beta. That is also important. No issue. Then, simple numerical. Look now. One more type of thing, no? One more type of thing. That is, if we have any 3D shape, my 3D shape. Okay. Now current is flowing from this terminal and leaving this terminal. This one, na beta? This terminal. This side is A, this side is B, and this one is C. So find a resistance. So sir, resistance is R equals to rho L by A. But this A means along the current. It is along the current. Done. Area is perpendicular to current. Perpendicular to current. Okay, now write for this one. Sir, R is equals to rho. What is L? It is along the current. What is the length of this particular side? Sir, it is length is I guess A. It is A. Area. Area should be perpendicular to current. I guess perpendicular to current. This area is there, no? What is the area of this particular thing? It is B into C. So I can write BC. So we can find the resistance like resistivity A divided by BC. I guess I am lagging now, beta. Okay, now we will change the direction of current. Okay, we will change the direction of current. How so? Look now, same cuboid or same this figure, 3D figure, same. Now current is flowing from this terminal and leaving this terminal. Okay, this side is A, we know it. This one is B and this one is C. Current is flowing in this way. So what is resistance? Sir, it is rho length. What is length? Length is along the current. Is it A? C, sorry, C. C divided by perpendicular area. I guess this area is there, no? Perpendicular one, it is A into B, AB. It is AB. Done? So you will find the PYQs, no? You will find PYQs. I guess this one is JEE PYQ, okay? This is JEE PYQ. So you should be very well prepared for your next examination. We need to be 100% perfect with all the concepts. We can change the parameters, right? Look now, one more thing. If we have a hollow cylinder, one more condition for hollow cylinder. If we have a hollow cylinder, you can see the quality of numericals, right? If we have a hollow cylinder, hollow now, hollow with length L, and it is radius is given by R. Current is flowing from this particular direction. Done. How to write now R? Sir, R is equals to rho L by A. Okay, sir, rho is rho, L is L. What is A? A is pi R square. Area of this particular end, no? Pi R square. Okay, one numerical from the same concept, but for solid one. If we have now solid cylinder, like look, one cylinder like this, is it's something like this, no? Look. Done? Length is L. Done, no? If the radius of the big one is A and the radius of the smaller one is B. So what is R? Sir, R is rho L by A. Rho is rho L is A. What is area? I guess area needs to be only this particular area, not this one. Only this area, no? Okay. So I will write it is pi R. What is R? R is A square minus pi B square. So it is rho L divided by pi A square minus B square. Okay. This is also JEPYQ. My Shabi are very big fans, sir. You can पैसा देखते हैं fans बाकी साल. One second, beta. One second. Okay. Now, next part. Okay. Next part. Next part is ohmic and non-ohmic graphs. Ohmic and non-ohmic graphs, right? First of all, Ohm's graphs or Ohm's law. Ohm's law means V is equals to I into R. Done? If we compare the equation with straight line equation, y equals to mx plus c, and we will make a graph between V and I. Okay, look here. Then now, look now. In you can see now this one is x-axis, this one is y-axis. So we have V in y-axis correct. We have I in x-axis correct. Now I guess here I can write here 0 as well. No issue. So my C is 0, intercept is 0. Okay. And R, what is R? R is M. M means slope. M means slope. So slope is R here, right? If I just draw a line, okay, this is theta. So this line represents slope and this slope represents resistance R. And it crosses 0, 0. That means intercept is 0. Now let's suppose we have a graph between I and V. Okay. In some case, if we have a graph between I and V, then look, we need to change this equation now. V equals to I into R, right? We need to change it now. So can I write now here I is equals to here V by I? No, it is not V by I, no? It is V by R. It is V by R. So y is equals to mx plus c. Here I will write 0, no issue. Still intercept is 0. Okay. In y-axis we have I. Yeah, y-axis we have I. In x-axis we have v. So x-axis we have this v. So m came out to be 1 by r. So my slope, this slope here, theta, this slope represents inverse of resistance. This slope represents inverse of resistance. If you have a graph between V and I, slope will give you the resistance. If you have a graph between I and V, slope is 1 by R. Slope is 1 by R. Done? Okay, this was based on Ohm's law. Let us do some numericals based on this Ohm's law, right? Look now, bit. We have graph. We have graph between V and I. Graph 1, 2. Resistance 1, R2. Choose the correct option. R1 is more than R2. Second one, R2 is more than R1. Third one, R1 is equals to R2. Fourth one, none of these. Which one is the correct option? First one, R1 more than R2. Second one, R2 more than R1. Third one, R1 equals to R3, or none of these. Okay, sir. So we need to firstly see the graph. Now, is it between V and I? Okay. That means this a particular line represents what? A resistance. Now, look, it is theta 1 and theta 2. So what is M? Son, M is slope. Slope is tan theta. Tan theta is resistance. You can see here theta 1 is more than theta 2, which indicates tan theta 1 is more than tan theta 2, which indicates R1 is more than R2. So option first, R1 is more than R2. You need to solve the numerical like this, okay? Second numerical. Second numerical. My numerical is now between I and V. Between I and V. Value of first one is R1, value of second one is R2. Okay, same. R1 more than R2. Second one, R2 more than R1. Third one, R1 equals to R2. Fourth one, none of these. Which one is correct now? Which one is correct now? Sir, graph between I and V. So M is tan theta. V is equals to 1 by R. Done, no? So tan theta is inversely proportional to my resistance. Okay, sir. So I can write, look now, this one is theta 1, it is theta 2. So I can write tan theta 1 is more than tan theta 2. Therefore, R1 is less than R2. Option number, which one? R2 is more than R1. Now, one tricky numerical. One tricky numerical. Okay, I will give you 1 minute for that one. One tricky numerical. And this one is a important one. Graph is between V and I. We have 1, 2. The temperature of first one is T1 and second one is T2. T1 more than T2. T2 more than T1. T1 equals to T2. Fourth, none of these. Think about this one now. Think about this one now. Huh? Sir, we only know that V, I, and R. Na. Here is temperature T. How to get this numerical done? Look, beta. We know that. We know one thing. Na? If we are increasing the temperature, what will happen now? Sir, resistance also increases in conductor. It increases in conductor, right? So look here, sir, theta 1, theta 2. So you can write tan theta 1 more than tan theta 2. So resistance R1 more than R2. So our temperature resistance is in a direct relation. So I can write T1 more than T2 also. First option. Okay, now? Okay. So we conclude the ohms now. We will start non-ohmic. 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 Non-ohmic means these are those devices which doesn't follow Ohm's law. Okay. Okay. So if you need to write for Ohm's law also, so I will write here, so in shorter way here, no? Ohm's law simply indicates, I will write Ohm's law means first part, Ohm's device. Now Ohm's law obey. Second line, straight line graph. Straight line karo or straight line graph. Okay, between V versus I or I versus V. Done. Second one is non-ohmic. Non-ohmic is also known as limitation. Limitation of Ohm's law. Limitation of Ohm's law. Done. So non-ohmic doesn't follow Ohm's law. First one. Second part, these graphs doesn't have straight line. Okay, not straight line between V and I. Non-ohmic means doesn't follow the ohmic law, the straight line karo. They have a curved path. No? It is not a straight line. Okay. So if you need some examples from your NCERT, in your NCERT, it is given like this. It is given like this. IV. You can see now, this is not a straight line curve. So it is an ohmic device curve. No? It is a diode curve basically. Okay. One important is given to us. It is gallium arsenic. It is important, and it is curve is given us like this. It is curve is given to us like this. Okay. In gallium arsenic, we have four sort of regions. We have four regions. Look, this region is straight line. This one is curved. No, look here. This one. This particular region is having negative slope. Negative slope. So negative slope indicates negative resistance. Negative resistance. Clear? And it is given in NCERT. That's why this one is very important. No? Gallium arsenic. It is gallium arsenic. You need to mention each and every information in your copy. Okay. So in the previous case, when we were dealing with the ohmic law, we know that how to find which resistance is more and which one is not more. Now in this curved path, how to get it? Look, beta. Look how to get it. Look now. For non-ohmic, we know that we have a curve like this, no? 2 points. First point is here. Second one here. The resistance of first one is R1. Second is R2. How to get its value? Make a tangent, no? Theta 1. Theta 2. I guess theta 1 is less than theta 2. So I can write tan theta 1 is less than tan theta 2. So I can write R1 is less than R2. So you need to manipulate your answers like this, no? You need to manipulate. You need to get your answers like this, okay? Like a pro. And I guess if you have watched my the backlog series of basic mathematics, no? I have shown this graph. Smiling graph. It is increasing graph. Okay. Now, two more important graphs in our syllabus from NCERT. One is copper graph. Second one is nichrome. Nichrome or nichrome. Okay. First one for copper, it looks like this. Look now. Resistivity here or resistance. This one is temperature. It looks like this. For nichrome or nichrome, it is temperature, it is resistivity, and it looks like this now. So we need to memorize, we need to get these things in our mind. Now, for copper, it is like exponential. Okay, for nichrome, it is straight line, but not getting from the with some intercept part. These two graphs are given in NCERT. If you can just open your NCERT, you can see these things. Okay, this one is from NCERT. Both things from NCERT. in your NCRT. Okay, in your odd pages. We will not talk about much about your semiconductors. Why? Because the last chapter of physics is semiconductor, no? So there we will have a very vast discussion based on the semiconductors. So here we will not waste our time, no, to discuss semiconductors. Look, I will give you some sort of revision thing. If we talk about conductor in conductors, if we talk about our conductors in conductors, if you are increasing the temperature, what will happen? The relaxation time decreases. If relaxation time decreases, so resistivity increases. If resistivity increases, so resistance increases. If we talk about semiconductor, if we talk about the semiconductors, in semiconductors, if we are increasing the temperature, with increasing the temperature, number of charged carriers increases, which eventually decrease your resistivities or your resistance decreases. This thing we will have a very deep discussion in a resistance or in semiconductor chapter. Okay. Okay. Now we have one of the most important things. One of the most important thing from our chapter, that is resistance temperature coefficient. What we have now, most important thing, that is, and it is derivation also, resistance temperature coefficient. Resistance temperature coefficient, it is alpha. I know that you are familiar with the alpha, right? It is resistance temperature coefficient, and it is equals to alpha is equals to change in a resistance divided by resistance whole divided by change in your temperature. This is the equation to get your alpha. I am not teaching in any school, na. I am not teaching in any school. Okay. So is it alpha delta R by R whole divided by delta T? So now here we will discuss some points. If we are talking about alpha could be positive, my alpha could be negative, my alpha could be 0. If my alpha is positive, so if we are increasing the temperature, resistance increases. Alpha positive simply indicates with increases in temperature, resistance increases. I guess this property belongs to conductors or metals. Then second one, alpha negative means if you are increasing the temperature, resistance decreases. I guess this property matches with what? Semiconductors. Yes, it is semiconductor as well as with your insulators. If alpha is 0, if you are increasing your temperature, so no effect, R is constant. If you are increasing temperature or if you are decreasing temperature, no effect on the resistances. So you will say my alpha is 0. Okay, and this is a PYQ, JEE PYQ. Easy, right? Look, conductor part we know, na sir. If temperature increases, time decreases, rho increases, R increases, I decreases. About the second part, how alpha is negative for semiconductor and insulator. We will be having a very great discussion in semiconductor chapter. Now, you know that equation R equals to R naught 1 plus alpha delta T. Let us derive this equation now. Let us now derive this one. Look beta. So how to derive it? What we know, sir, we know that alpha is equals to delta R by R whole divided by delta T, right? So now I can write it like, sir, it is 1 by R delta R by delta T. Or I can write it as in differential form 1 by R dr by dt. So my alpha came out to be, sir, it is 1 by R dr by dt. So can I write here, sir, alpha del dt is equals to dr by R, or 1 by R dr equals to alpha delta t. I need to now take the integration of it. If my time is initial, we will having a resistance R initial. If my time is final, so sorry, the temperature is final, so my resistance would be final, RF. I will give you the values of T, na. Wait and just here, na. Look. Wait for a couple of minutes. I will give the answer, right? Wait a couple of minutes. So this equation, what is the integration of 1 by R? Sir, it is ln of R. It is ln of R. Upper limit is R final, lower is R initial. Okay, alpha is constant. I will take it outside. So integration of dt would be only T. Upper limit is T final, lower is T initial. So I will write here ln. Upper limit is R final minus lower is R initial equals to alpha. Here upper is T final, lower is T initial. If we are taking the ln here, it will become E. So I can write R final minus R initial. Or I can do one more thing. Now I can do one more thing. Ln of A minus B. Can I write ln of R final divided by R initial? I can write like this now. Huh? I think I can write like this. Look now. So I can write R final by R initial equals to e to the power alpha. Now T final minus T initial. Here we need to take some assumptions. Assumption means difference needs to be very small. Difference, that is T final minus T initial, it is approximately very small, and alpha is constant. These are assumptions. Okay, first one is difference needs to be very small, alpha is constant. Third is my temperature should be in degree centigrade. First one, difference should be very small, alpha needs to be constant, and the temperature that we are using, it needs to be in degree centigrade. It is not compulsory, but in our syllabus we need to take these three assumptions, right? Look now, you know that if we have something now, if we have something E alpha or E power x, okay, or E alpha x, I will write like this now. It is E plus alpha suppose fx, and it is very small, so I can write it equals to 1 plus alpha x. So therefore I can write now R final, R initial equals to 1 plus alpha T final minus T initial. So therefore final resistance is equals to initial resistance 1 plus alpha temperature final minus temperature initial. So this is your equation, final equation. Final equation. This one is your final equation. And this is only valid if the difference is very small. Alpha needs to be constant. Okay? Done? Done, beta? And generally, we have some pointers. Generally, we are taking the initial temperature as 0 degree centigrade. Or if given, it is equals to 27 degree centigrade. It is given. If it is not given, so we need to take it as a 0 degree. In some cases, it is given as 27. So initial temperature is always 0 or 27. This formula, yes, we can change it at the end now. We can change it. There is no issue. I will show you some numericals. Now, look, we are doing the derivation. So specifically here, we need to deal with this degree centigrade only. But later on, we can change it with the Kelvin. Now, there is no issue. Done? But here, if we are applying the formula, my temperature must be, it should be, it needs to be in temperature only. It is necessary condition. Yes. Done? So you need to write, this one is must condition, this one. It is must condition. Done, beta? Now we will do some numericals. Very simple numericals firstly, then we will just increase the level, okay? Look now. First numerical. First numerical is NEET PYQ. It is NEET PYQ and a very easy one. We have a conductor. It is having 50 at 50 degrees centigrade. It is resistance is given as 5 ohm. Okay. Now, if we change the temperature to 100 degrees centigrade, it is resistance changes to 6 ohm. Find. First part, what is alpha? Second part, what is initial resistance? These two things we need to find. Two things. Sir, what is alpha? What is R naught? Initial resistance. Sir, how to get it? What is equation? Sir, my equation R is equals to R naught 1 plus alpha T final minus T initial. Okay. What is given to us? Sir, R. What is R? R is 5. So can I write for first one? It is 5 is equals to R naught 1 plus alpha. T final, is it 50 degree? Yes, it is 50 degree. Minus initial is always we need to take a 0. I told you, no? Okay. Now for second one. What to write? Sir, is it 6? Yes. R naught, same R naught. Okay, sir. 1 plus alpha. Temperature is 100. Minus initial is 0. Okay, sir. Let us divide these two equations now. Look, R naught cancel out. So can I write now it is 5 by 6 equals to 1 plus 50 times alpha divided by 1 plus 100 times alpha. Now we will solve it now. So I can write 5 plus 500 alpha equals to 6 plus 300 alpha. So I can write 200 alpha equals to 6 minus 1, it is 1. So alpha came out to be 1 divided by 200. So alpha came out to be 1 divided by 200. Okay. 1 by 200. It is per degree centigrade. Now I can write per degree centigrade. Now for R naught, I will take this equation now. So I can write 5 is equals to R naught 1 plus alpha. Alpha is 1 divided by 200 into 50. 0, 0 cancel out. 5 ones are 5, 5 fours are 20. So 5 is equals to R naught. It is 4, it is 5 by 4. So therefore, 5, 5 cancel out. So my R naught came out to be 4 ohm. This came out to be 4 ohm. Easy or super easy? Easy or super easy? It was a NEET PYQ. Easy or super easy? Huh? Easy or super easy? Okay, now next numerical. If my temperature is in Kelvins, na, Patil sahab, no. Now, if my temperature is in Kelvins now, how to deal it? One more NEET PYQ. One more NEET PYQ. Look, at 300 Kelvin, my resistance is 1 ohm. Now, at what temperature it is resistance will become now 2 ohm. It is resistance will become 2 ohm. Look, temperature is in Kelvins, but if we need to apply the formula, if we want to apply the formula, we need to change the Kelvin into degree centigrade. Then only we can use the formula. Okay, sir, how we can get it? Alpha is also given. Alpha is 0.00125 degree centigrade. Okay, now use the formula. Sir, R equals to R naught 1 plus alpha delta T. It is given to us. Okay, sir. For first one, what is R? R is 1. Is R not given to us? No, sir. R naught is not given to us. Okay. 1 plus alpha. Alpha is given to us, no? I will write alpha is alpha and then I will cut it. What is delta T? Sir, 300 Kelvin means 27 degrees centigrade. So I will write 27 minus 0. Initially 0. For second one. For second one. Okay. I can write 2. Is it 2? R naught is R naught. 1 plus alpha is alpha. Temperature we don't know. Just divide it now. R naught cancel out. So my equation came out to be 1 by 2. It is 1 plus 27 alpha divided by 1 plus T alpha. So I can write here 1 plus T alpha equals to, it is 2 plus 54 alpha. Done now? So I can write T alpha minus 54 alpha equals to 2 minus 1 is 1. I can take alpha common. It is T minus 54. It is 1 only. So T minus 54 came out to be 1 divided by alpha. 1 by alpha. Done now. So T minus 54, 1 by what is alpha? Alpha is 0.00125. So look, 0 cancel out. It is 1, 2, 3, 4, 5. I can write 1, 2, 3, 4, 5. So T minus 54 equals to 800. Okay, it is. So what is T now? So T came out to be 800 plus 54. So the T came out to be 854 degrees centigrade. If you want to get in Kelvins, what do you need to do? In Kelvins, na? In Kelvin, I will write 854 plus 273. It is in Kelvins. 43721. It is 1127 Kelvin. Look, after we have Kelvin, before numerical we have Kelvin. Lekin if we are applying the numerical, we need to apply it in only in what? Degree centigrade. Okay, we can't use it in Kelvin or in other format. Now we need to use in what? In Kelvin only. Yes, that one is 273. Nah? Yeah, you are very intelligent, right? Look now. Let us suppose some derivation also, right? Some derivation. An important one also. Look now. If we have, look now. Suppose, so we have two wires at 0 degree centigrade. Clear? First wire is having resistance R1 and alpha 1. Second wire is having resistance R2 and alpha 2. Is find alpha in series. Find alpha in series. Good. This one is very a good sort of derivation. Okay. Alpha in series. Okay, sir. If this is my first wire, second wire, resistance is R1 and R2. So now, what will be the series resistance? It is R1 plus R2. It will be R1 plus R2. So can I write now, sir? R in series means it is R1 plus R2. Now differentiate both sides with temperature. So I can write it is dRs divided by dt equals to d divided by dt of R1 plus d divided by dt of R2. I guess we know the equation now. Alpha equals to 1 divided by R. It is dr by dt, right? So dr by dt is nothing. It is alpha times R. So here it is Rs. So I can write alpha S Rs equals to alpha 1 R1 plus alpha 2 R2. So I need what? I need alpha S. I need alpha S. So my alpha S came out to be alpha 1 R1 plus alpha 2 R2 whole divided by Rs. And Rs is R1 plus R2. I will write alpha 1 R1 alpha 2 R2 whole divided by R1 plus R2. Done? Look beta. Important thing. If R1 equals to R2 equals to R0, then I can write beta what? Alpha 1 R naught, alpha 2 R naught, R naught plus R naught. Then I will write R naught common, alpha 1 plus alpha 2. It is R naught into 2. R naught cancel out. It is alpha 1 plus alpha 2 by 2. Important. It simply indicates if we are having two wires with the same resistances and with the coefficient of temperature is alpha 1 and alpha 2, what is the series temperature coefficient? It will be alpha 1 plus alpha 2 divided by 2. But this is only valid if the initial resistance is same. If initial is not same, write alpha 1 R1 plus alpha 2 R2 whole divided by R1 plus R. Interesting or boring? What happens? One second. Okay, now my network is still some sort of issue. Now there is an issue with my network also. So I will wait for 1 minute so that it gets clear. Then I will start. 1 minute, beta. 1 minute. So this formula is same as a battery combination like E1 R2 divided by E2 R1 divided by. You will get many things same now in repetition way, right? But you need to remember it. Okay, but there is E2 R2 E1 R2, right? Different one. Here is alpha 1 R1 alpha 2 R2. Now second case, if two lines are what? We are connecting them in a parallel way. 12 o'clock we will end our lecture, right? One wire R1 alpha 1. Second wire R2 alpha 2. Now look. It is R1 alpha 1. R2 alpha 2. What is 1 divided by RP? Parallel na 1 by R1 plus 1 by R2. Okay. How to write it now? Yes, sir. But due to some network issue, na, sometimes it lags. No? After 10:30 here in my area, there is a network issue. Every day it's lagging. No? But after every 10:30. Okay. So can I write now? 1 divided by R parallel equals to 1 divided by R1 plus 1 divided by R2. Done? I can write like this, no? Now, differentiate. Differentiate both sides with temperature. Okay. What is the differentiation? But every day, 10 from 10:30, I am taking classes every day because we need to finish my whole 12th syllabus before the September, right? And after September, we are planning to launch 11th also. Then some foundation 9th and 10th also for NEET and JEE, na? Not for the for basics. Differentiated. So what is the differentiation? Let us suppose my differentiation is d divided by dx. Differentiation of 1 by x. Okay, I will write x minus 1. So I can write, sir, so minus 1, x minus 1 minus 1, it is minus 1 minus x minus 2. So I can write minus 1 by x2. In the same way, differentiation of 1 by rp would be 1 divided by rp square, then drp divided by dt equals to minus 1 divided by r1 square dr1 divided by dt minus 1 divided by r2 square dr2 divided by dt. Okay, look, I will cancel out the whole negative part now. So I will write 1 divided by rp square drp divided by dt equals to 1 divided by r1 square dr1 divided by dt plus 1 divided by dr square dr2 divided by dt. Done? Okay, so I will write here 1 divided by rp square. In place of drp divided by dt, I will write what? It is rp alpha p equals to 1 divided by r1 square. In this place, I will write alpha 1 r1 plus 1 divided by r2 square. I will write alpha 2 r2. R21, R21 cancel out, R1, R1 cancel out, RP1, RP cancel out. It is alpha P divided by RP equals to alpha 1 divided by R1 plus alpha 2 divided by R2. Done? It is mathematical calculation now. We need to get it done. Okay. So I will write alpha P divided by RP is equals to alpha 1 R2 plus alpha 2 R1 whole divided by R1 R2. What is RP? Do you know what is RP? Yes, sir. It is alpha P. RP means 1 divided by RP is equals to 1 divided by R1 plus 1 divided by R2. So 1 divided by RP means it is R1 plus R2 whole divided by R1, R2. So here I can write, sir, it is R1 plus R2 whole divided by R1, R2. So it is alpha 1 R2 plus alpha 2 R1 whole divided by R1 R2. Clear? So this one cut us with this one. So therefore, one second. So it is 1 by RP. Okay. So what is alpha P now? It is R1 alpha 2 plus R2 alpha 1 whole divided by R1 plus R2. I guess this is my final expression. This one is my final expression. Okay, it is R1 alpha 2 R2 alpha 1 divided by R1 plus R2. Same case, if R1 equals to R2 equals to R0, you will be surprised that alpha P would be how much? Alpha 1 plus alpha 2 divided by 2. The resistances are same. So in series combination, my alpha, and in parallel combination, my alpha, both are same. Both will be same. Both will be same, right? Am I lagging too much? Am I lagging too much? Do I need to cancel today's class then? Am I lagging too much? Then I will cancel today's class. Huh? Am I lagging too much? Then I will just complete the rest part in tomorrow's class. I think I'm lagging very much. No, 1 second. There is a lot of issue with the network, right? So I will wait for 1 minute now. If it gets clear, then we will start. If not, then I guess better would be if we'll take tomorrow, not the rest things, right? Shall we continue today's session? Shall we continue this session? We can do one thing now. We can do one thing. Tomorrow is off, Sunday. So I can take one thing. I will take a small lecture, right? Suppose a lecture of 30 minutes tomorrow, because it is lagging now, so it won't be a very good decision now. And it is lagging, so you may lose your interest in class, right? So I'm thinking that tomorrow for half an hour I will take a class, so that I will complete this resistance topic. From Monday we will take the circuit diagrams. Okay, parallel, then series. Okay, we'll take those diagrams then, right? And every day, every at 10:30 I am taking class. Every day 10:30 I am taking class. Okay, and if you are new, so you can do one thing. You can go to my channel description part. You will find my Telegram link, so you can join the Telegram also. And after my this lecture series, I am going to upload the PDF file of the this particular chapter, so that you will revise the whole thing, right? Tomorrow 10:30 same timing. 10:30 to 11, no? Same time. Okay. So have a great night. Study well. Okay. And if you find any difficulty, na, if you find any difficulty, you can just reach out to me via the Telegram, or you can just ping me the comment. I am just regularly checking the comments also. Okay. If you have any sorts of issues or any you want any mentorship, also these things like that. So I will be giving a very good response from my end. So, but only one thing that I need from your thing. Yeah, beta, only physics, right? I'm one person, right? So I will be only delivering the physics part. Okay. In a day, only 2 hours particular timing is free from me. No, I'm not having a very great time free. No, I guess this class is my 11th class in a day. Okay, so I am having that much of stuff to be done in one day, right? But somehow I managed to get you guys a very great thing, right? You can see the content of my classes. So yes, if you have any sort of issues or anything like that, you can just come at me. And our goal is to complete the whole syllabus before any one. Okay, beta. How do you feel? How do you feel? How do you feel then? No issue now. We will complete the 11th also. Okay. After the 12th, so in September, most probably we will start our 11th. And August, September, October, November, na? And December. In December, we will complete the 11th also. Then you will have a lot of time to revise your things na, for your board examinations. And if you're in NEET and something in JEE, na, you will revise the whole thing in January, February, March, April, right? You will have 4 to 5 months to revise these things. And that is great. Now this is a revision class for you then. If you have completed the whole the first part of NCRT, right, up to the EM waves, then it's a revision sessions for you. Yeah, in JEE also, na, only 5 to 10% the difference between JEE and NEET, na. That's everything is same, right? Yeah, in JEE, some portion is extra, something is extra, but I am covering those extra things also there, right? Some extra derivations part. Yeah, I know the Navodaya schools, right? Navodaya schools, the centralized schools in India, right? I know. Okay, I guess we need to just take now rest. Okay, tomorrow we have a very big day. Okay, in all the edtechs we have the examinations, right? So bye, beta. Prepare well for your examinations. Bye. Thank you, and we will have a class most probably tomorrow for a very quick recap on this things to be completed now, the resistance part. so that we will complete the syllabus. Okay. Thank you, beta. Thank you very much. Bye. Maharashtra, Pune. Yes, that's great. I was in Maharashtra a couple of years back in Karad. Okay, in Stara Karad side. So I know some little bit of Maharashtra as well. No issue.